Hello Cloud Pedagogians, welcome back to the course. In today's session, we are going to implement the VPC in our student directory application. In this scenario, you will create the underlying network infrastructure in which the student directory EC2 instance will live. In this exercise, you will set up a new VPC with 4 subnets, which are nothing but 2 public and 2 private. Also, we'll create 2 route tables, which are again 1 public and 1 private. Then you will launch an EC2 instance inside the new VPC which you have created. Finally, at the end of the lab, you will stop the instance to prevent future costs from incurring. So let's start. First, we will create a VPC and then we will attach the VPC to the internet gateway. And then we will create subnets which are private and public. Next, we will create the route tables and look into the ACLs that are created by the AWS. And then we will add security groups while launching the EC2 instance. And then finally, you will stop the instance so that you don't get charged. So first we will create a VPC. If you are looking at the console, you will first check to make sure that you are in the correct region by clicking in the upper right hand corner. Right now, we are going to run in North Virginia region. So we will go ahead and make sure that this says in Virginia. Once we choose the right region, we can now build our network. You will type VPC in the service search bar and that will bring up your VPC dashboard for this region. From there, you will click on your VPC and then create VPC. Now we have few settings to configure. Select VPC only in resource to create section. Enter a VPC name which we will say is student app VPC and enter IPv4 CIDR range which is 10.1.0.0/16. We will leave the rest as default and then click create VPC. Easy as that. Congrats, you have successfully created the VPC. Next, we need to attach this VPC to the internet gateway so that it can communicate to the outside of the internet world. Back in the VPC dashboard, you will click on Internet Gateways in the side panel. Then click Create Internet Gateway. You will give the internet gateway a name, say Student IGW. On the details page, you will then select the Actions drop-down box and select Attach to VPC. Choosing the Student App VPC we have been working with and then you will click Attach. Congrats, you have attached your VPC successfully to your newly created gateway. Next, we need to create the subnets. So let's create the subnets. Let's go ahead and start creating the public subnet. Back in the console, we will click on subnets in the side panel and select create subnet. Then we will select the VPC we are working with. In this case, it's the student app VPC that we just created. Once you do that, you will be prompted to provide a name. We will call this public subnet 1. Then we choose the AZ US East 1A and then the IP range of this subnet will be 10.1.1.0/24. We will leave the rest as the defaults. Now scroll down to the bottom and click Add New Subnet. Enter the subnet name as public subnet 2 and we choose AZ US East 2B and then the IP range of this subnet will be 10.1.2.0/24. So the public subnets are created. Now we are going to repeat the same steps for our private subnet. Give it a name such as private subnet 1 and put it in the same availability zone US East 1A and then type in IP range 10.1.3.0/24. Again, create another private subnet 2, and we choose the availability zone AZ US East 2B with CIDR IP range 10.1.4.0/24. Now we can click Create Subnet. And 4 subnets will be created successfully. Here you can see 4 subnets are created. Now select the checkbox next to Public Subnet 1, choose Actions, click Edit Subnet Settings. Now enable the checkbox next to Enable Auto Assign Public IPv4 Address. Click on Save. Do the same thing for Public Subnet 2 as well. Congratulations! You have created 2 public subnets, 2 private subnets successfully. Next, we will create the route tables and look into the ACLs that are created by the AWS. Let's see a quick example of the main route table. Let's hop into the console. Here in the VPC console, we will click on the route tables on the side panel. That will bring up all of the route tables that exist in this region. If we scroll to the side, you can see the main column and the VPC column. We are going to look for the main route table for the student app VPC. When we click on it, we bring up the bottom panel and then click on routes. Here we can see the local route that has a destination of the VPC IP range. This means that all of the components inside of our VPC can communicate with one another locally by default. This local route will be present in every route table that you create. Alright, that's the main route table. Now we create a custom route table and associating it to our public subnet. Let's go ahead and get started. Let's create the route table for our public subnet. Back in the VPC console again, we will click on the route tables on the side panel and then create route table. We will give it a name such as Student App Route Table Public. Choose the Student App VPC in the network and then click Create. Okay, our route table is now created, but we are not done yet. We still have to edit the routes to allow traffic to flow from the internet gateway. And then we will go to the routes section in the bottom summary table. We will click Edit Routes, Add Route, put 0.0.0.0/ for the destination, meaning it can take and deliver traffic from anywhere, and then we will specify the target as an internet gateway. This will bring up available internet gateways to attach it to, and from here we will select the Student App Internet Gateway. We are done with the route, so we will click Save. Now the route table is created, but we need to associate it with this subnet. If we only want this route table to apply to our public subnets, we will need to associate with our 2 public subnets only. To do this, we will click on the Subnet Association tab, select Edit Subnet Associations and choose the public subnets we created earlier. Then click Save. So you can see here that the subnet itself isn't providing the public access. It's the configuration of the routes. Alright, we have hooked up our public subnets to a route table that allows internet traffic from the internet gateway to our student directory application. If we wanted to create a route table for the private subnets, we would follow similar steps. You would create the route table, make sure there is no route to the internet gateway this time, and then associate it to the private subnets. Let's do it. Okay, we have now configured our route to the internet gateway. We will configure additional firewalls rules later on. So, congratulations, you have created the subnets successfully. Now it's the time to add security groups while launching EC2 instance. Let's build out a security group for our student directory application. The default configuration of a security group blocks all inbound traffic and allows all outbound traffic. If you want your EC2 instance to accept traffic from the internet, you will need to open up inbound ports. If you have a web server, you might need to accept HTTP and HTTPS requests to allow that type of traffic through your security group. You can create an inbound rule that will allow port 80 and port 443, where we are going to apply them in a moment. The beauty of security groups is that I don't have to open up an outbound port for traffic to be able to leave the instance. That's because security groups are considered to be stateful resources. They will remember if a connection is originally initiated by the EC2 instance or from the outside and temporarily allow traffic to respond without having to modify the inbound rules. Remember that security groups and network ACLs are powerful tools to filter network-wide traffic for a single instance or subnet traffic. With security groups, everything is blocked by default, so you can only use allow rules, whereas with network ACLs, everything is allowed by default. But you can use both allow and deny rules too. So let's go ahead and launch the EC2 instance. Search for EC2 in the search bar at the top or choose the EC2. Click on Launch Instance. Enter a name for EC2 instance, Student App Server. Select the AMI, Amazon Linux to AMI. Create a key pair, student key. In the network settings, that's where we will select our newly created VPC in this section. Click on Edit, select the Student App VPC in the VPC section. In the subnet session, select one of the public subnets that we have created earlier. In the Security Group section, select Create Security Group. Enter security group name Student App SG and give some description. Here you can see the SSH port is open. That's okay to keep it, and we will add security group rules for HTTP and HTTPS. Select type HTTP and enter source with 0.0.0/0. And now add again HTTPS with same source 0.0.0.0/0. If you want to add any other ports, like for example, my application runs on port 8080. So here I'm going to add another rule for that, which allows port 8080. Select the IAM role which we have created in IAM lab. In the user script, copy the user code. As you can see here, my Flask application runs on port 8081. That's the reason I have added a new security group rule that accepts the port 8081. So go ahead and launch the instance. As you can see, The application is up and running. Let's go ahead and run the application. Copy the IP address and put 8081 next to it so that it works. As you can see here, the student directory application is up and running. But it's not fully functionally working because we did not add resources like storage, S3, DynamoDB databases in the AWS. Congrats! You have launched an easy-to instance hosting your student directory application into a customized VPC. To prevent future cost, obviously you will now stop the instance. Choose Instance State and click on Stop Instance. Click Stop. The instance state will eventually go into the stopped stage. Congratulations! You have created a customized VPC for your student directory application. I hope this is useful and helpful for you. Looking forward to seeing you again in my next video. Until then, take care.